should be recording this. I'll just do it just in case. I may or may not post it. So this semester I'm doing something a little bit different. I decided to have quizzes every other week with my classes, not just you guys. Normally I'm the guy that I give a quiz every week because I think practicing is important. There is a story that involves the great Jhevon Newman. Do any of you know that name? Okay. So let's just say he is a genius. So has anyone ever seen the movie Good Will Hunting?
Yes.
Okay, you know how Matt Damon was in that movie? Jhevon Newman, that's it. Okay, so people like that, they're very rare. You can probably go your entire life and never meet one. Most people never do. Generations of your family can go live their lives and never meet someone like that. Jhevon Newman was such a person. And there is a story about a conversation that he had with this grad student. I think he was a physics grad student. And he came and he was worried and he was like, oh, I don't know, these classes are tough. I don't know if I have what it takes to actually, finish this PhD and do the work. Everything's so hard. How do you understand everything so well? And what Von Neumann said to the guy was, my boy, you don't understand math. You just get used to it. And there's more wisdom in that saying than you would realize. You get used to it. It's something that you get used to. A lot of people are concerned about how much they understand. Shut up and get used to it. Practice all the time. Do problems. Do it intelligently, and we'll be talking about that a little bit. But at the end of the day, math is something you're going to get used to. And oftentimes people don't, because when they do bad, they kind of avoid it, they don't study, they never really try hard because they kind of don't believe that they can do it on some level. But we will talk about that, if not today, in the coming weeks. So my idea what I would do with non-quiz recitation sessions was, yes, maybe answer some questions and go over quizzes, maybe some homework problems towards the end. But what I really wanted to do was to just maybe talk at you guys for a little bit. So like the first 20 or 30 minutes of every recitation session, I'm pretty much going to just be ranting at you, kind of telling you how to be a good math student, how you want to think about things, how you want to approach your studies, just kind of how you want to organize yourself, how, if you're in a bad situation, how do you actually get better without wasting any time? How do you study and know you're studying right, and know you're going to walk into an exam and do well, as opposed to, I thought I did better than this, I don't know what happened, which I hear all the time. I really understand the material, and then you get like a D. Like, why does that happen? I want to take this time to explain to you guys why things like that happen, and how you can avoid it happening to you, and just in general how to be a better student. And so, a part of these sessions are going to be like that, and the other part I'll probably do questions and answers. At this time, I don't have a lot of data on this particular class to kind of dive into what the issues are and deal with them immediately. So I'll probably for today just kind of flip things on their head and talk about this first. And then maybe start to kind of set things up, kind of set up a general framework in which you want to operate, hopefully, and then we'll kind of fill in some specifics as the weeks go on. But let's look at quiz 1. I just want to go over some things that stood out to me. So this one covered actually prereq material. Now, as I said, the answers are online, so the point isn't really to give you the answers, but to kind of explain some things that would kind of jump out on me. So the first thing that jumped out on me is that not everyone got problem 1 correct. Now, that is very bad. That's something that I will talk about later on. But it's not really something I'm going to go over right now because it's memorization. Memorize it, copy it on the paper. Okay? So we'll deal with that pretty soon. And again, that's just something you get used to, right? And several of these was on the practice quiz that I went through with you guys before, so you would have seen the answers already, but several people got that wrong. A lot of people got problem 2 wrong. So these were the limit problems. So I just want to talk about those. when it came to problem 2, I would say most people got it wrong. There were a few who got it right, there were some people who got part of it right, but I'm not even sure if they were thinking about it in the right way, so I'm going to go over it just in case. So that was part A, and I don't know if I'll have enough space for it, but let's do it over here, part B. Now, a lot of people thought 1 was the answer for part B. And someone even wrote a little note on the paper so I know what they were thinking why they got 1 as the answer for part B. The answer isn't 1, but here's the problem. So it was that guy. Now, the reasoning that the student gave to me was, well, the power is going to, well, x is going to infinity, so ln x is going to infinity, so 1 over 2 ln x must go to 0. So you have something raised to the 0 power, so the answer should be 1. What is the problem with this logic? Because that's not the right answer. Yeah.
Is it an indefinite form?
It's an indeterminate form, that's the name for it. Why? What makes it indeterminate?
Because it's infinity to infinity.
Right, because, well, it's not infinity, this is 0.
Infinity.
So yeah, the power is going to 0, but you can't ignore the base. There's an x here. The base is going to infinity. This is infinity to the 0. It's an indeterminate form, which means the answer is non-obvious. You have to actually do some calculations for it. So that was 1. A lot of people just wrote down 1 here. I'm not sure if they just looked at the power to see that it was 0 and they just said, oh, it must be 1. But that was an indeterminate form. That one is less straightforward than you think. It's not as complicated as you might think, but it's less straightforward than you think. What about this one? How did you actually approach this one? Not as many people, but quite a few people here got infinity as the answer. The answer is actually 0. What do you guys think is the approach here? I don't want to spend too much time on this. We have a subtraction of logs. You should have a log rule memorized that tells you how to deal with that. Log of A minus log of B equals? No. Log of A over B. So that is that. Now, ln is a continuous function. In Calc 1, you would learn that limits can pass through continuous functions. So this is really going to be ln of. And what is this?
It's 0 over 0. So you use log rules for both.
Right, you can, but it is also something that you should have memorized. The limit as x approaches 0 sine x over x, as well as x over sine x. That's kind of something you should have like memorized right away.
It's 1.
It's 1, right? That should. So this actually approaches 1. So the answer approaches ln 1. So the answer here is 0. So I did actually have more space. So this one, it wasn't as simple as the power going to 0. You have to pay attention to the rest of the problem because there are things known as indeterminate forms. And this happens to be one of them. So knowing that it's an indeterminate form, what would you do here? The people who recognize it, people who got it right, if you're not too shy. Hopefully you're not too shy. So this is an indeterminate form because it approaches infinity to the 0, which is not necessarily 1. Could be 1, but it's not obvious. You have to actually do some calculations here. It could not exist. It could be 1, it could be 0, it could be some other random number. What would you do here? And not exactly this problem. I believe we went over a similar problem on the quiz before. Maybe it was this, I don't remember, like x to the x or something like that. If x approaches 0 from the right, or we did something similar to this. Whenever there's a power that's giving you trouble, what is the first thing that you think about to actually deal with that situation? What allows us to get rid of powers?
Logs.
Huh?
Logs.
Logs. Logs allow us to get rid of powers. Here I have 0, infinity to the 0. It's kind of where the power is a variable, so I'd want to use a log to get rid of it. There are a couple ways we can apply logs here. You can set this equal to y and log both sides and then deal with the right side, and then you'd have to remember to raise both sides to the e afterwards. Or you can just remember there's another rule that we learned back in Calc 1, is that e to the ln of anything is just a thing. So we can actually rewrite this as e to the ln of 1 plus 2x to the 1 over 2 ln x. And the log rule tells us that the power can now come down and not be a power anymore. So this is going to be the limit as x approaches infinity of e to the ln of 1 plus 2x over 2 ln x. Right, and I don't think I'll get to this today, but this is something I'm going to talk about in general, like just having a strategy for each situation. You should know, if I'm in a situation where a power is a problem, a log should be the first thing to come to your mind, right? There are certain things that should trigger certain thoughts in the student who gets used to mathematics. Certain things just follow automatically based on the situation you're in. And problematic powers, logs follow automatically. It should be the very next thought once you notice something like that. You don't have to do this, but I guess it might be, just want to show you that it is a thing. Again, logs, limits pass through continuous functions. That was again something. So technically I can take this limit, pass it through the exponential. And so this really becomes e to the limit as x goes to infinity of ln of 1 plus 2x over ln 2 ln x. Now, how do we deal with that situation? So now the e is going to be in the base no matter what. How do we deal with the power? How do we deal with this limit?
If you take the 2 and use it to x squared, then you have 2 ln's divided. Can you not transform that into 1 plus 2x minus x squared?
No. Why? That's important. Why not? What does the rule say? The rule that you're trying to quote.
Oh, it's like, if you have, oh, because it has to already be inside. If you have ln there, then
Right, this is the rule,
yeah.
right? Here, there's only one ln beside the division. Here, we have 2 ln's. It doesn't fit the rule, right? This is one of the reasons why when I usually give quizzes, like problem 1 is just going to be me asking you, regurgitate the rule. What is the formula for this? What is the general formula for that? Because that's important. It's going to be easy to mess up if you don't have the rules really tight in your mind. Probably I'll talk about that in one of these coming weeks, like how important it is to just memorize the rules and really know them very well. So you don't apply them when you shouldn't be applying them. So that doesn't apply here. What else can we actually apply here? Yeah.
Can you use L'Hopital's?
L'Hopital's. This goes to infinity over infinity. So I'm going to apply L'Hopital's rule. And derivative of the top over derivative of the bottom. And I get that. And I'd be able to simplify that a little bit. Just flip and multiply. I would get x over 1 plus 2x. Now, this is the limit of a polynomial. We know that when we see that, we focus on the highest powers. The highest power is 1 in the top and the bottom. Since the highest power is the same in the top and bottom, this ratio goes to what? 1/2. Goes to the ratio of the leading coefficients. So e to the half is the answer. So those are from 2. 3a, most people got that correct. The people who got that wrong, they had really weird answers. I have no idea what actually happened, so nothing to really quote there. B, most people also got that correct. If you didn't, it was just some mix up with the quotient rule. A lot of people forgot the 2. That was the thing. So this is 3b. Y was 7 squared over cube root of 2x plus 1. And you're supposed to find y prime. And using the quotient rule, completely fine. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom. All over the bottom squared. So it's 2/3. There were quite a few people who almost got this correct. Believe it or not, most people forgot this little 2 here. That was actually a very common mistake. So people forgot to use the chain rule on this guy to have to multiply by the derivative of the inside. If you got to that, I gave you the point. I mean, the answers that I put online, these guys, I actually simplified a little bit. But if you wrote this out, I would have given you the point. You didn't have to simplify. C. Now this one was supposed to be easy, and most people did get this one right as well. But there were a couple people who got it wrong for a very special reason. So, normally when I'm teaching Calc 1 and I talk about the quotient rule, I always also talk about situations in which you don't want to use the quotient rule. So usually if you have a fraction where either the top or the denominator is a constant, applying the quotient rule is usually a waste of time, and at worst, you can make a mistake and get the wrong answer. And usually, what I would say is the people who do apply the quotient rule and get the answer wrong, it's usually because they forget to actually differentiate the derivative of the constant is going to be 0. And that actually happened with 1 or 2 people. So again, here, I would not use the quotient rule. The denominator is a constant. The derivative is, leave the denominator alone, differentiate the top. Right? And that was the answer. Some people decide to apply the quotient rule. Now, in general, this is not incorrect, but it's very inefficient. So you're going to do the bottom times the derivative of the top, which is this, minus the top times the derivative of the bottom, all over the bottom squared. Now, a 0 should go here, which should indicate that you just wasted your time writing out a bunch of stuff that you didn't have to. But what often happens is that people usually just copy the constant back, which is what happened on a couple of papers this time around. So yeah, again, there are times when certain things I recommend, not necessarily because it's the right way to do things, but just in general, it kind of minimizes your chances for making errors. And I also tend to tell people these things in class. And let's see here. The integration, most people got A, B, most people got most of the integration correct. As one thing that was also weird, I would comment on this, is that a lot of people, there were a lot of people who got this graph. The one for y equals x cubed minus 4x. Now, I expected naive sketches here. I didn't expect you to go through that whole curve sketching process where you're like find concavity and all that, and I didn't care about all of that. I just kind of expected you to pretty much find the intercepts and just sketch it. So if you want to find the x-intercepts, for example, you set y equal to 0, There are also a few people plotting points, which is kind of weird. You shouldn't be plotting points to sketch something like this. So you set that equal to 0, you factor this, factor that. So you know that the x-intercepts are 0, which also implies that the y-intercept is 0, plus or minus 2. And so you would actually just plot a point here, 0, plot a point here, minus 2, plot a point here, that's positive 2. Now hopefully you know that a cubic has at most 2 turns, and because it's positive, the right side would be going up and the left side would be going down. So this picture is obvious. If it's not obvious, what you would do is you would just test each interval by plugging in random numbers. So you plug in a 1 into the expression. This is probably the nicer version to plug it into. So if you plug in a 1 here, you get a positive times a negative, which tells you the graph should be underneath the x-axis. If you plug in a minus 1, you get a negative times a positive times a negative, which gives you that the graph should be positive. You should know the end behavior, but let's say you didn't. You plug in a 3 on that side. That's a positive, 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 so you know that the graph should be up here. And if you plug in a minus 3, that would be negative times negative times negative, which is negative. And you pretty much just sort of connect the dots as you're passing through these intercepts. Right, and that will get you the picture there. So that was how it should have been done, or that's the quickest way to do it, how I would expect you to do it. One thing that struck me though, is a lot of people decided to identify the maximum point. Now once you actually put it on the paper, now I have to grade it. Like if you didn't do it, everything was fine, but a lot of people decided to identify that point as having y value 3 for some reason. Now, I don't know why they decided to choose 3 to be the y value for that point. How would you actually, if you had to, how would you find the maximum point of this polynomial? If finding a max point is your goal. Yeah?
Just find when the derivative is equal to 0.
Find when the derivative is equal to 0. So you go y prime is equal to 3x squared minus 4. And you set equal to 0. This gives you critical points. Technically it's 0 or undefined that will give you critical points, but it's a polynomial, so it's never undefined. So you only have to end up sketching this, so that's x squared equals 4/3, so your x would be 2 over radical 3. And so the max point would happen at plus or minus 2 over radical 3. So this one is going to happen at minus 2 over radical 3. This one is going to happen at somewhere like positive 2 over radical 3. And now to actually find the y value, you have to actually take that number and plug into that, and you would not get 3. Okay. But some people, and it was usually the people who decide to do the plot points method, because 3 happened to be the point that they picked that gave the highest value. They decide, oh, that must be the highest value. No, you just happen to pick that, which you shouldn't be picking it because you don't need to. What?
If you just use 1 and negative 1 to check, like we talked about, and you just happen to give yourself a little outline to follow and you drew it, and then you, do you know what I'm saying? Like if you check the points like you told us to do,
Yeah.
and you just give yourself a little, this is my outline,
Yeah.
of the line.
Yes.
How was I?
That's
I
very
didn't
different.
check
That's
for
very
max
different than specifically identifying a max point, though.
But what if you didn't want to?
Oh, you didn't have to.
No, but.
You didn't have to. Like I didn't require it.
No, but what if I didn't, okay.
I didn't require it, so you didn't have to do it. Right. So just be careful with those things. Don't identify maximums and minimums. You're a calculus, right? So we're not in the realm of guessing maximums and minimums anymore. We actually know exactly how to find it. So if you're going to find it properly. So yeah, those are just some comments. Like I said, the answers are online, so you can go over the quiz again, work through the problems. And do that. Yeah, and pretty much any problem you got wrong, I would actually go back to Calc 1, look at that topic, do a few practice problems, like really study it again. Because it kind of, a lot of the times certain things, certain deficiencies are in the background causing you to get things wrong in future levels like Calc 2, and you're not really going to know what they are. So this diagnostic was really kind of meant to prod at the errors that you might make and just make you aware of them. And hopefully by going through this and me just talking about a few things here will kind of tell you how you sort of want to think about problems, what you would notice, what should pop out, and when something pops out, what you should actually do. Hey, this power makes things complicated. What should I do in that case? Logarithm. I have to get a logarithm in here somehow, right? So that's just the general thing. So next week we will have another quiz. So the quizzes aren't cumulative, so they're really based on what I did the previous week. So since we've been just doing integration techniques, the quiz next week is just going to have, I'll probably ask you a few general formulas again because it's good for you to know the general formulas, but then it's just going to, hey, compute all these integrals, where you might have to use by parts, you might have to use substitution, you might have to use several integration rules at a time. Now, let's talk about the remaining time. Let's talk about the general framework in which I think is going to be better for you to operate. So, how to improve. Okay. In whatever, right? Whatever, if you're not happy with your grade, how do you do better the next time? Or how do you do better over time? How do you go from a situation of, I'm not getting the results I want, to, okay, now I'm getting the results I want? How do you move from one phase to the next phase? The details can be a little sketchy, and again, I'll be revealing some as we move on, but I kind of want you to have like a general approach or a general sense of how you're going to attack things. Okay? So step one is you need a target. So you're going to set a goal. Okay? Now, I can't tell you what that goal should be. So for this class, I'd say the goal should be an A, right? Okay, my goal is to get an A. Now, goals, good goals are specific, they're measurable, I was going to say timely, but maybe that's also, and timely, okay? So, if you want to say, oh, my goal is to do well in this class, that's actually a bad goal. That's not a good way to set a goal. What does that actually mean? You want to make it specific, measurable, and timely. So, for example, you might want to say, okay, I want like a B in this class, at least. Right? Now, in order to get that, you need to make sure that by the time the final comes around, you are hitting a certain number. So a B starts at an 80. So you would say something like, my goal is to get an 80 on the final by December 10th or whatever, right? You have to be very specific. That's automatically measurable because the number itself is a measure, but you're going to be very specific. Not, I want to do well. You're going to say, I want an 80 or above. Make it very specific. Give yourself a time limit. You set a goal for like someday, or I kind of just want to be good. It's not really going to happen, and yeah, it's not really going to happen. So that's the first thing. Two, you need, it might be here, but if not, you want to find a why. There are two things, or you're going to need a lot of discipline. One or the other. I think this one is more powerful, but it's kind of hard to actually create one if you don't already have one. So, you want to do well, you want to get better at something, you need to know why you want to do well or get better at something. Now, there are bad ways to pick goals, there are also bad ways to pick whys. And it's going to sound weird coming from like a math science guy, but it needs to be emotional. It can't be a logical reason. Well, I want to get better because, you know, my degree requirements. Like, no, it's not going to work. You need an emotional reason why you want to do well. So, I want to make my family proud of me, or something like that. It has to be something that's not really logical. It's just something that is emotional, that gets you going. Because what's going to happen is, if you really are in a situation where you really need to improve, like you're at an F and you want to get to a B, it's going to take a lot of hard work to get from that F to that B, and it's going to have a lot of frustrating ups and downs, and to actually power you through those ups and downs, emotions are what's going to do it, not logic, right? Reason and logic doesn't get you to do anything, believe it or not, right? Everyone knows better than what they're currently doing. Everyone knows, oh, I should be eating better, I should be exercising more, I should be doing this. You know logically things that you should be doing, but few people ever actually follow through on those. Because you knowing what to do doesn't actually get you to do anything. What does get you to do something? I don't feel like it. How you feel gets you to do something. Your emotions actually get you to do something. So you need an emotional reason why it's important for you to achieve this goal. If not, learn how to become a disciplined person. And in a weird way, if you're not a disciplined person, you can actually improve your discipline using this exact scheme I'm showing you now. So one or the other, either can work. This way is better if you can get it to work. So maybe just think about it. Maybe try to think, why am I in school? Why am I doing math? Why am I majoring in what I'm majoring in? What do I want to accomplish? What kind of life do I want? How do I want to feel? Start thinking about it. Why are you here? Now, so that's it. You're going to set a goal, one that you haven't achieved yet, one that is, you know, your dream goal. You're going to have an emotional reason why you want to do it, or just be a disciplined person who can grind through anything. The third thing you're going to want to now have is have a way to objectively assess yourself. Now this one is pretty tough because usually we do not assess ourselves very well, myself included. This is a problem for all human beings. The way you think of yourself is pretty much almost never correct. Right? So you are going to want to have an objective way of actually measuring how you're actually doing. Luckily for you guys, in a class, your grade does that. So if you feel like, oh yeah, I understand everything, I'm awesome, and you get a bad grade back, that's kind of telling you what you think of yourself and what's actually the reality are different things, right? Emotionally, you might not ever agree with your grade, but it's graded objectively. Like, your answer doesn't look like that answer, there's an X. If it does, there's a check, right? It's an objective standard. The number is telling you the truth. Now, like I said, usually this is going to be emotionally painful. You're going to feel like this number doesn't describe me. But trust me, you need an objective way to assess yourself. Because if you believe that you're here and you want to get here, when really you're here, what's going to happen? You're going to think you need to put in this amount of work when you really need to put in this amount of work. And so you're going to be like, I'm working hard enough to get a good grade in this class. Why am I not getting a good grade? You misdiagnosed where you were. It's not good enough to know where you want to go. You need to know where you start. Your GPS isn't going to work if you don't know your starting position. You need an objective way to know your starting position. Now, whatever it is, don't get discouraged, no matter how bad it is. You can get that goal. It's just going to take a certain orientation to make sure you're orienting yourself correctly. So you need an objective thing outside of yourself, usually, that is going to actually tell me where I am. You're never going to actually know. If people tend to have anxiety or depression problems, they'll tend to underestimate themselves Whereas most other people overestimate themselves. It's very hard to actually get an accurate view of where you are. And like I said, this is everybody. This is a human condition problem. This is everybody. Now 4, you're going to have a plan to improve. Now, a lot of what I'll be talking about over the coming weeks is going to be this, what is a good plan to improve versus a bad plan to improve. But once you realize, okay, I'm at an F, I need to get a B, there has to be a road that is going to take me from this F to that B. I need to plan out that road, okay? And some roads are better to take than others. We'll talk about that a little bit more as time goes on. And probably what I'm going to say at the end is kind of going to sort of tell you where you want to go with the plan. And 5 is the persevere. Just stick with it. Rinse and repeat 3 and 4 until the goal is achieved. Do not stop until the goal is achieved. Now, if you don't have step 2 in place, step 5 is going to be difficult to impossible for you to do. Step 2 is what's going to allow you to do step 5. Step 5 is going to tell you, keep repeating 3 and 4 until you achieve the goal. You're going to do something, you're going to assess your results, compare to what the goal should be. If you're not there, have a plan to improve. Apply the plan, test yourself again, see, are you where you're supposed to be? No, plan to improve. Assess yourself again, check with your goal, am I where am I supposed to be? No, plan to improve, assess yourself, it's going to be that. And trust me, there are going to be ups and downs, because there are going to be times when you apply a plan and you're like, yeah, this is awesome, I'm doing great. Okay, yeah, I feel like I'm getting it now, blah, blah, blah. And then you assess yourself, it's going to be like, womp. And now it's like, I suck at this, I give up. Maybe my dad was right, maybe some people are made for math, or whatever. You're going to have like some messed up reasons in your head for why this is happening to you. Maybe Jhevon just hates me, just being like harsh for no reason, you know? And it's like, no, once you're there, it's going to be really hard to continue. What makes you continue that cycle is step 2. Right? You're either going to be like, well, the goal isn't achieved, so I'm going to go right back into it, and that's discipline. Or, you know, it's like, no, I'm going to show my dad that I'm worth something. You know? Like you're going to use that emotional reason to actually push yourself to actually go through the cycle again. Okay? Now, this is something that is often an issue in applying the above. This is important. Specificity is key. Specificity is super important. Specificity is why there are some bad plans versus good plans. Because you might have a student who is doing bad, like they took a test, they thought they were ready, they were prepared, and they get a bad grade back, and I don't understand what's going on, you know? And let's say they actually don't get down on themselves, they don't blame someone outside of themselves, and they actually, okay, you know what, I'm gonna do better next time, right? And they actually jump back in there, right? And they start to go through this cycle. And so they decide, okay, you know, for the next test I'm gonna do well, I'm gonna like double, do all the homework problems over again, and blah, 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 right? And that's their plan. I'm gonna redo the homework, get all these problems done, and, you know, the next test I'm gonna be ready. And a lot of times they go through a plan, and on the next test, maybe they do slightly better, but a lot of times they don't do as better as they wanted to do. And usually when something like that is the problem, when you implement a plan and the results are mediocre. Now, to be fair, sometimes it takes some time for the results to reveal itself, but there are some things that should really be quick, and you should kind of sense how quick it should be. In calculus class, nothing should really ever take a really long time. Right, like if you don't understand integration by parts and it takes you like 2 months to understand, something is wrong. Your plan isn't efficient. But let's say you do something and it just didn't work out. Chances are the problem is you're not being specific enough, right? There's something known in sports as specificity of training. It's basically the idea that you want to train at the thing you want to get better at. Now, when you're not in math class, this seems to make perfect sense. You want to get better at basketball? Play basketball, right? That makes sense. You want to get better at playing the piano? Play the piano, right? You want to get better at public speaking? Speak in public. These are obvious things when you're not in math class. But when you're in math class, students really don't take it that obviously, right? So the thing is, if you are, and sometimes what you're doing might help you towards your goal, but it is not actually attacking it. It's kind of like going around it. So it's like, let's say your goal is, I'm gonna have a race, I wanna win this race a week from now, and it's like a 100-meter sprint. But all your practice is you jogging around the block for a long time. You basically doing marathon running. Now technically, they're both kinds of running, right? You're training running, and to you, you might think, well, I'm training running, I'm training my stamina, I'm getting cardio in, but just running around jogging around your block is very different from going all out for 100 meters as fast as you can. They are different enough, right? It's not a specific enough stimulus. You want to train for a sprint, you have to sprint. You have to sprint at some point. If all you do is jog it, or walk on a treadmill, or do leg extensions, you're not going to get there. You have to actually sprint at some point. So, for example, to the student who thinks, okay, the way I'm going to improve is just to do a lot of homework. Here's the thing. If you do a lot of homework, you're going to get good at doing homework. Specificity is key. You want to do well on a test, you know what you're supposed to do? Tests. Right? So if you're like, oh, I should do better in this test because I understand what's going in class. Sitting in a class, listening to me talk is different from you doing a test. Now sure, listening to me would help you do better on a test, but it's not actually you putting in a plan to get better on a test. If you try to get better at tests by doing homework and paying attention to lectures and watching YouTube videos, those things are all good and they will help you, but it's not going to like measurably go towards it. At any given time, you want to assess yourself in a way that's very specific to the goal. So whenever you do all that stuff, if your goal was to get better results on a test, you have to follow up with an assessment of yourself taking tests, right? And this is why if you go and buy if you go and purchase any Kaplan course or anything, you have this big textbook where they talk about test strategies, but what's always contained in those books? A bunch of practice tests, right? You think there's a reason for that maybe, that these people who guarantee a higher tester score give you a test packet for you to practice a bunch of tests, because specificity is key. You want to get better at doing quizzes? Do more quizzes. You want to get better at doing tests? Do more tests. You want to get better at homework? Do more homework. Every time you want to apply this strategy, be very specific. Now, you can do other things around. Yeah, if you're going for that sprint next week, yes, you should be eating properly. Yes, you should be sleeping properly. Yes, do some jogging, get your cardio under. Yes, you can be doing all these things. But at the end of the day, the most important thing to do is to actually sprint. Actually get some practice sprinting, right? So if you do all these side things and think it's going to dramatically improve your test-taking skills, it's not going to work. And then what you're going to have is really a bad plan, and it's really going to be harder to persevere because you're going to feel like you're spinning your wheels and nothing is getting better, right? So, specific goal, have a reason to continue in that goal, an objective way to assess yourself, plan to improve. Your plan must take into account the specificity of the particular thing you want to improve in, and rinse and repeat. Now at any given time when you're making your assessment, if you're too far from your goal, obviously maybe sometimes you might have to tweak your plan a little bit. You're going to have to tweak step 4 a little bit. But in general, this is how it's going to get done. This is like the general framework in which I want you to think about improving and how you're going to actually achieve something. And yeah, this is very general, and over the next few weeks I'll start talking about things about how are you going to actually do this in a math class specifically. So how do you actually go about objectively assessing yourself? Besides my grades, because you don't really want to use my grades to assess yourself. You kind of want to have like your own set of grades so that by the time you assess yourself and work through this plan, by the time my test comes around, you do well on it, right? Failure is important, but you don't want to fail at the wrong times, right? Like, you know the dates for the tests, for the exam 1, exam 2, and the final. Make sure those 3 days are not the times failure happens. Failure happens in between them. Work out all the bugs, all the kinks between those time periods, right? And things are gonna not work out, and you're gonna have to try something else, and then it's gonna not work out, and you're gonna try, and that might work out a little bit, okay, I'm gonna do more of that, maybe try a little bit of this. It's going to take some tweaking. But of course, when it comes to math, specificity is key, and this is what I'm gonna help you guys with. Specifically, how do you actually go about applying this to a class? And we'll pick up with that next week, we're pretty much out of time. So next week, like I said, we have a quiz. That'll be on integration techniques, whatever we do up to Thursday. And I believe I have Warburg.